Hi class, this is the video analyzing the argument form of analogy in some detail. A reminder, these lectures do not take the place of the reading but are supposed to supplement it and clarify some things. And so with that in mind, I just wanted to express one of the reasons I'm doing what I'm doing in terms of introducing the argument forms and the fallacies is those are not distinct. A lot of times textbook authors have those in separate chapters and the students just don't make the right kind of connections as a result. For instance, if you're learning fallacies, then all of a sudden every analogy becomes a weak analogy, and that's not the way you do it. Fallacies and arguments are not on other sides of the world here. They should be read in tandem, and being aware of fallacies is what helps us make better arguments. So I just wanted to get that out of the way. Second thing to say is, why are we starting with analogy? It's not because it's alphabetical order. There's something very interesting and important going on with analogy. Analogy is probably our first and most basic form of inductive argument. It's all based on the notion that like causes like. And this is the most basic reasoning tool. An infant who burns their hand on the stove is not going to touch the stove again because uh, they are aware in some sense that similar cause will yield a similar effect. And so analogy doesn't get emphasized often enough outside of inductive logic, but we use it all the time. So think of when we're trying to decide uh, what team is going to win in a sporting event. A lot of times we call that a prediction, but really predictions are supposed to say that the future is the same as the past. But when we're talking about the same teams playing again, they're not actually the same, even if they just played yesterday in a baseball three-game series. There's different weather conditions, different pitchers, everybody's feeling a little different that day, better or worse rested, things like that. And so to infer anything that we don't know that isn't identical to something we do know is really a form of analogical reasoning. So it's this omnipresent, very basic, very important form of reasoning that we don't pay enough attention to. But as we mentioned, the whole point of critical thinking, if we learn to be articulating our reasoning, if we are being very explicit about what our inference is and what our reasons are, we're going to make them much better. And so by slowing down and saying what's really going on in analogies when they go right and when they go wrong should be very helpful for our critical thinking. So any analogy takes the following form. Entity A has properties X, Y, and Z. Entity B has properties X and Y, dot, dot, dot. Therefore, entity B has property Z. Now, that is its most general form. Let me start making some clarifications. One, there don't need to be exactly two of these things. So we can add things wherever. So I could say entity B has properties J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. Entity B has properties J through Y. And those are the similarities that are driving the inference. Doesn't have to be two. I just get lazy there. But second of all, you could actually add more entities. Entity A has properties X, Y, and Z. Entities B has properties X, Y, Z. Entity C has properties X, Y, Z. Entity D has properties X, Y, and therefore Z. That's what an analogy does. Notice it requires a couple of things. One, it requires an entity A. What's entity A? Something we know has property Z. Something we are aware of has property Z. When it's something we know has the property, that's called a primary analog. So analogy needs at least one. Sometimes people like to mix in several. What do the primary analogs have in common? That you know they have the property Z. The secondary analog is what I called entity B in the first example. The secondary analog is the thing we are inferring has property Z. So just to go back to the original simple argument then, entity A, primary analog, has properties X, Y, and Z. We know A has Z in the premise. Entity B has properties X and Y. Therefore, inference, entity B, secondary analog, also has property Z. So to run an analogy, you have to have at least one primary and secondary analog. Some logic texts let you stack up as many primary analogs as you want. I feel a little funny about that because at a certain point, you're just going to blend together analogies and generalizations. We'll talk about generalizations later. All right, so we know what the analogs are now, entities A and B. What's property Z? The thing we're inferring in the secondary analog. Well, what's this XY then, or however many? Those are the similarities that drive the inference. So that's where we want the analogy to be. Now, what makes it a good analogy? Well, there's really two things. So depending on your textbook, they can stack up a few more. But the general idea is the number of relevant similarities, the X, Y, etc. And we have to have something besides raw number. Why? Take any two objects, and I mean any two objects. My red pen, my antique cell phone. Well, how many things do they have in common? How many similarities do they have? Infinite, if you really want to stack them up. Let me give you some stupid and trivial examples. They both have more than one molecule. They both have more than two molecules. They both have more than three molecules. Well, that gets you the first couple billion. They are both east of California. They are both south of Canada. There's all these similarities that we could stack up. So potentially infinite number of similarities and dissimilarities, by the way. Well, of these two, my phone is closer to Florida. My pen is closer to Canada, et cetera, et cetera. You could talk about, I don't know how many molecules each of these has, but obviously this one has more, and you can list a bunch of dissimilarities based on it. This one has more than X molecules. This one has more than X plus 1 molecules, X plus 2. So ideally in an analogy, we want relevant similarities. I say ideally because one thing that happens in the sciences is you're never actually very sure, well, not never, you're sometimes not actually sure if a similarity is relevant. If you don't fully understand a genome and you're doing genetic sequencing and, well, they both have this particular structure of this gene, you don't know if the gene has anything to do with the medical condition you're examining. So more similarities is better in some sense, but we want non-trivial similarities, which means ideally we want relevant similarities. So the first major evaluation of analogy is the number of relevant similarities given in the argument. But there's a second one that people forget sometimes, is the absence of a disanalogy. And that could be very important too. If there's obvious disanalogies, those are such that they're going to block or at least severely undercut the inference. So let me give my favorite simple example. I like to give this example because I have a friend who was a tutor for this course a few times when I taught at a different institution. And he'd always know these examples were about him and he'd just grumble. But anyway, suppose I gave the following analogy. Adolf Hitler had a mustache, was a teetotaler, never drank alcohol, and was a genocidal maniac. My good friend who works in bioethics has a mustache and is a teetotaler. Therefore, he's a genocidal maniac. All right. First, before we evaluate this terrible, terrible analogy, start with our terminology. So it is an analogy First of all, it has a primary analog, something we know has Z. So Hitler, we know, was a genocidal maniac. Then we have a secondary analog, something we are inferring has property Z. My good friend who works in bioethics, I am inferring, is a genocidal maniac. What is the basis of that inference? The given similarities in the premises. Both have a mustache. Both are teetotalers. All right. Why is that a bad analogy? It actually violates both of the criteria that I gave for evaluating analogies. So first of all, the similarities are no more interesting than south of Canada because they're not relevant. And let me say a word or two about relevance. There's no such thing as relevant in general. Let me say that again. There's no such thing as relevant in general. So there's no such thing as mustaches being relevant in general or mustaches being irrelevant in general because they may be relevant or irrelevant depending on what we're talking about. There's only relevant to Z because that's our inference. So is having a mustache relevant to whether you're a genocidal maniac? No, we know that. Why do we know that? Well, there's lots of people who have mustaches who aren't, and there's lots of people, unfortunately, who don't have mustaches who are, which means we know having our mustache is irrelevant to your genocidal tendencies. And the same can be said for being a teetotaler, not drinking any alcohol. Well, there are bad we know that that's not just causally connected to genocide for similar reasons. And so first and foremost, I have given no relevant similarities to think that that is a good analogy. But second of all, there's an important disanalogy. I don't just say my good friend, I keep saying my good friend who works in bioethics. When you have a PhD in a field whose sole goal is to improve humanity, that's very relevant to whether you're doing the most immoral thing imaginable. And so there's not only no good similarities, there are important dissimilarities. So the analogies can fail for one or the other or both. But again, remember there's no such thing as relevant and irrelevant generally, only to Z. So Mickey is bald. Well, that is relevant if you are drawing an analogy based on appearance, that Mickey looks like Stone Cold Steve Austin in some way. So, but it's certainly not relevant to whether I'm a genocidal madman. So key to remember, no such thing as relevant and irrelevant generally. And the other thing we have to watch for is important disanalogies. That is things that would undermine the inference. So let me give a few more examples. So here's an analogy, and it's an example of why analogical reasoning is so common. I, as a professor, when I'm building this course, when I'm building this exam, when I'm building the exams, etc., lean heavily on analogies because you, the people in this class, have never taken my course before, this course. So I don't have any type of experience of same, which means I have to use similar. What am I going to do? I'm going to look at last semester. So I might say, well, last semester, the students were about comparable, about the same size, about the same distribution of freshman, sophomore, junior, senior, etc. Used the and did okay on exam 1, tiny bit shaky, but okay, and then really improved on exam 2. This class, well, I know I've used same already. So this class is similar in its freshman, sophomore, junior, senior composition, similar in things like material, obviously, and setup and what's in the unit. And I might say, therefore, they're going to do about the same. A little shaky on unit 1, but rally in unit 2. Well, that overall is not a bad analogy. So first of all, notice I gave several similarities. Course composition and content, breakdown. Obviously, you're both students at the same institution. It's the same course, prereqs, etc. There's lots of uh, similarities, and those tend to be relevant to exam performance, which is what we're inferring. Now, so overall, I might say that is a decent analogy. And it might even seem strong, but you also want to stop and think, well, are there disanalogies? So far with this course, you might not know this, but I'll give you two disanalogies. So one, because the class was a little shaky on the unit one, I've presented that material a little differently. I tried to add some in the videos and give more practice problems and the like. And so we would hope that might, in fact, increase the performance on exam one. But two, and this is cutting the other way, this class to date is really, really, really underutilizing the discussion boards, unlike last class. And so I might expect exam scores to be a little worse because anytime students are not fully using a resource, you tend to see that reflected on exam grades. And so notice, it's probably still a pretty good analogy. I'd probably still be willing to put some money on the conclusion that is a little shaky on exam one, rally on exam two. But because of those disanalogies, I'm less certain of my conclusion. Put another way, remember that strength admits to degrees. I would say that if there weren't those disanalogies, it would be stronger. But because there are disanalogies, it weakens it, but it's still a strong argument. And so that's what those are. All right, so that's analogies generally. Let's talk about when they go wrong. Quite simply, that is what Dowden calls the fallacy of faulty comparison, or most authors just call the fallacy of weak analogy. Well, one of those two criteria falls short, the evaluative criteria. So either there's not enough similarities, or the similarities are not relevant, or there's a dissimilarity that is substantive enough to actually change the conclusion entirely. So whenever you say fallacy of faulty comparison or weak analogy, really that's just any way an argument from analogy goes bad. But the three primary suspects: lack of similarities, lack of relevance of the given similarities, or there is a disanalogy, stated or unstated, that is significant enough to overcome those similarities. So that's what we look for in analogies. Let's have a good discussion week on those and pay special attention to when they go wrong. We'll talk to you next time.